This is Algebra 2, Unit 11, Lesson 9 on sinusoidal modeling. Now, the sine and cosine functions can be used to model a variety of real-world phenomena that are periodic, which means they repeat in predictable patterns. So the key to constructing or interpreting a sinusoidal model is to understanding the physical meanings of the coefficients we've been exploring. All right, so let's take a look at the coefficients again just to review. For y equals a sine bx plus c and y equals a cosine bx plus c. A, the absolute value of a, is the amplitude or distance the sinusoidal model rises or falls above the midline. Remember, if it's negative, it's still going to be a distance, so you're going to use a positive distance, and the negative just means it's going to reflect over the x-axis. Okay, c is the midline. That's where you're going to be measuring your amplitude from. So it is the c value. It kind of works as the axis when you move it up or down. Okay, b is the frequency of the sinusoidal model. It's related to the period by the equation bp equals 2 pi. All right, frequency means how often does it happen within a certain period of time. How often do you have a repeated graph? All right, and the period of the sinusoidal model is the minimum distance along the x-axis for the cycle to repeat. So how long does it take for one full cycle of either the sine or cosine graph to happen? That's the period. Okay, so now that we know that, let's use these to apply to a real-world situation. All right, the tides in a particular bay can be modeled with the equation of the form d equals a cosine bt plus c, where t represents the number of hours since high tide, okay, and d represents the depth of the water in the bay. The maximum depth of the water is 36 feet, the minimum depth is 22 feet, and high tide is hit every 12 hours. Okay, so on the axis, sketch a graph of the scenario for 2 full periods. Label the points on this curve that represent high and low tide. Okay, so we're looking for the number of hours since high tide. So at high tide, it would be the maximum depth. So this would be y max right here. This would be high tide. That's what you would start at. All right, so you're starting at 36 feet. So I'll put 36 right here. All right, and then it is going to go down in a cosine graph, so it's going to look something like this to be cosine. So it's got to go down to a minimum depth of 22. So y min will be 22. So the graph will go down like this to 22 and then come back up. All right, so this will be 22 down here. And then it'll come back up to high tide at 36. All right, and it says high tide is hit every 12 hours. So this time right here will be 12 hours. Okay, so if this is halfway down, this is one full cycle, that means that this would have to be at 6 hours, because this is halfway between that. Okay, so this is, and it said to sketch the graph for 2 full periods. So this is 1 full period, and then this would be 2 full periods. So it's going to happen again. So that would be 24 hours at the end of the day. This would be 22 again. And since this is a halfway between 12 and 24, this is going to be 18 right here. So when you have this value, your graph is going to look something like this. Okay, so let's determine the values of a, b, and c in the model and verify your answers and write the equation. Okay, so let's see what we can come up with on this. All right, we know that c will be the midline. All right, so let's find the midline on this. We want to look at this graph and figure out the distance so that the you are halfway between the high and the low. So if y min is 22 and y max is 36, we want to find the distance that's halfway between them. All right, so if we want to find half the distance between 36 and 22, we want the average. So c is going to equal the average of 22 plus 36 divided by 2. So this is going to be 58, divided by 2, which is 29. So half the distance between this is going to be 29. Let me do it as a dotted line so we can see where it is. Okay, so 29 would be about here. That would be half the distance. for there. So that's going to be the C value. So C is going to equal 29. All right, so if C is 29, if this is the average distance between these, what you want to look at is now what would be the amplitude. All right, the amplitude would be the distance from here to here. All right, it's the distance above and below the midline. All right, so that is going to be the difference between here and here. So we know this is going to be 29. So what is the amplitude going to be? The amplitude is going to be absolute value of 7, because this is 7 here and 7 here. So the amplitude is going to be 7. So we know A is 7. All right, so now we know A, we know C. Now we need to figure out B. All right, now remember B can be found using the formula BP is equal to 2 pi. All right, so we have to know our period in order to find the frequency. All right, so our period here, high tide is going to hit every 12 hours. So we have one full cycle of a cosine graph over 12 hours. So P is going to equal 12. So if we have P is equal to 12 and we solve this, we get B times 12 equals 2 pi. All right, solving this for B, we get B is equal to 2 pi over 12, which is pi over 6. Okay, so now we know what A, B, and C are. Let's see if we can write our equation. Our equation, I'll put it up here. D is equal to A, which was 7, cosine of pi over 6 t plus 29. All right, so let's put this on the calculator and make sure that this is what we ended up with when we did this. Okay, so y equals, let's put in our equation, 7 cosine pi over 6 x, and we're going to use x for t, plus 29. All right, now I need to set my window so it looks like what's on the screen. So first of all, I want to make sure I'm in radian mode, which I am. All right, I go to my window. All right, now our time was from 0 to 24 hours. So 0 to 24 will be my time for x's. And my scale, remember on our graph that we did, our scale here is going in increments of 6 hours. Okay, so our scale is going to be by 6s. So I can see here going up and coming down. So this is going to be by 6s, 6 hours. All right, now for our y's, 36 was our max, so we want to go a little past that. So let's go, I'm going to go a little negative just so that we can see below it a little bit. So I'll say -4 and say to 40. That way we can see exactly how much of the graph is there. All right, so that's all our values. So all we have to do is hit graph. All right, and that looks like what we have on our paper. So there we go. Okay. Now, tanker boats cannot be in the bay when the depth of water is less than or equal to 25 feet. Set up an inequality and solve it graphically. All right, so we're going to solve this graphically to determine all points in the line T on the interval from 0 to 24 when tankers cannot be in the bay. All right, so our equation that we found was D equals 7 cosine pi over 6 cosine pi over 6 t plus 29. All right, but we want that to be less than or equal to 25 feet. So the depth would have to be less than or equal to 25 feet. So if we take this equation, 7 cosine pi over 6 t plus 29 has to be less than or equal to 25. All right, so what we need to do is set up and solve it graphically. We are going to put D equal to 25 on our calculator. So let's do D equals 25, which will be a horizontal line. All right, so I go to Y equals, I'm going to be D equals 25. All right, so if I graph that, it's going to go down like this. Let me put that on my picture. All right, so here's my picture. We draw a line across. I'll do it in blue so we can find it. So 25 would be about here. Okay, now this is 25, And we want to know when the depth is the time interval where it's going to be less than 25. All right, so that would be from here to here and from here to here. So we need to know what these values are. All right, so if we go to our calculator, we're looking for this right here. So we're going to do an intersect. Second, trace key, intersect. I want to use the blue graph. I want to use the red graph. And then I want to pick out specifically, I'm going to move my arrow key over here to this point right here. Enter. And it jumps to here, so this is going to be approximately 4.2. So this is going to be 4.2. Oops. 4.2 is right here. Okay, and then that's going to stop at this point right here. So I'm going to do the same thing. Second, trace, intersect, enter, enter, and then I'm going to move over to here. Enter, and I get 7.8. So this one's going to be at 7.8 right here. Okay, so my first interval that I have for that is going to be from 4.2 to 7.8. And then my second interval, where it's less than or equal to 25, would be from here to here. So if I do those, intersect, enter, enter, and then move over to here, get close to it. You don't have to be right on top of it, but close to it. Press enter. That's going to be 16.2 approximately. All right, so that one's going to be 16.2. And then the other one, last one, enter, enter, and then move over to here, enter, and I get 19.8. Okay, so my values right there, this is going to be 16.2, and this one's going to be at 19.8, and anything that's below that will be less than or equal to 25 feet. Okay, so we have created the graph and then used it to answer the question. All right, let's take a look at exercise 2. The height of a yo-yo above the ground can be well modeled using the equation h equals 1.75 cosine pi t plus 2.25, where h represents the height of the yo-yo in feet above the ground, and t represents the time in seconds since the yo was first dropped from its maximum height. Okay, so determine the maximum and minimum heights that the yo-yo reaches above the ground. Show the calculations that lead to your answers. Okay, so if we think about this, your graph, if you're going to drop your yo-yo, it's going to go down like this and come back up as cosine. All right, so what we need to know is the maximum minimum heights that the yo-yo reaches. So that has to do with the amplitude and the midline. So what is the midline? Well, C is going to be 2.25 because that would be this value right here. And the amplitude is going to be 1.75. So it's going to be, the Y max is going to be 2.25 at the midline plus 1.75. So Y max will be at 4 feet. Okay, and then Y min will be starting at the midline 2.25, 1.75 below that. And then 2.25 minus 1.75 is 0.5 feet. All right, so what we have just sketched here is this. We started at 4 feet, and it came down to 1/2 foot and then came back up. All right, so this came down to 0.5 and then came back up. All right, so how much time does it take for a yo-yo to return to its maximum height for the first time? Okay, that has to do with the period and the frequency. Okay, so let's finish this in class for the next day, and we'll work on that.